Welcome and hello. This is a video lesson in RIMS, and in this lesson, I'm going to be talking about conditionals, specifically conditional expressions, conditional state variables, and conditional goal variables or constraints. So we're going to see how that works in RIMS. What I have on the screen is the Russell Plus reference manual on page 9 and 10 right here, where it talks about conditional expressions. A conditional expression is a comparison expression or a group of comparison expressions, meaning it's basically a expression that can evaluate to either true or false. And then in the case of a group comparison expression, that's like a compound comparison where you have operators like or, and, or not joining multiple conditional expressions together. If we scroll down a little bit further, we get a couple examples like x plus y equals z times the maximum of a, b, and c. And then below that, an example, a compound with an and right there. And then right down here, we have a way to define a conditional state variable based on what looks like the month. I'm going to go ahead and bring up a model schematic of a model that I'm working on. I might build this out in its entirety in an upcoming example video, but this is just a lesson. We've got two reservoirs. They each have their own inflow. They each have their own storage. Reservoir 1 flows into Reservoir 2, so these are in series. And then downstream of that, at nodes 5 and 4, we have demands. So there's a time series associated with the inflow, a time series associated with both of the demands. We're not going to look at all the data and how it's all built in this lesson, but what I do want to focus on is here in the decision variables, I'm going to look at the reservoir storage volumes over the course of this simulation. This simulation is a 5-year simulation, Reservoir 1 and Reservoir 2. So Reservoir 1 is in green. Both reservoirs started about 580,000 acre feet for storage. Reservoir 1 has a higher priority for storage. That's why they both top out for the first half of the simulation. And actually, Reservoir 1 is almost completely full except for a little bit here in the year 1925. Reservoir 2 has a storage that tops out at 1,000,000 acre feet, and then starting at about 1924, it drops down to zero to satisfy some of the downstream demands. What I want to do for my first example here is a conditional state variable. In the Russell Plus reference manual that is on page 16 is where that's set. There we are. Conditional state variables, they may be assigned based on the user specified conditions. So the way that you type them into the Russell language is you go svar and then the variable name, open bracket, and then case. Give the case a name, and then after that, you want a condition term. Here's your conditional term that evaluates to true or false, and then after that, the actual value. So what's actually just as helpful for me is to look at an example. Here, for instance, the state variable's name is going to be nm test. The two cases are February and others, and then the condition here is whether the month equals February or not, and then that particular value is assigned. So I'm going to go over to my channels.russell file right here. Okay, cool. It's already up. I have decision variables defined for channels 1, 2, 2, 3, 3, 5, and 3, 4. Now 3, 5, and 3, 4 each have 3 decision variables just because there's a downstream inflow demand and there's a coefficient in the objective function associated with satisfying the minimum value flow for those two reaches. All right, starting at line 12 here, I'm going to paste in this block of code. And what I'm doing is calculating the storage difference between reservoirs 1 and reservoirs 2. Now, there's probably other ways to do this besides how I'm doing it using a conditional state variable here. But the name of the variable is going to be store underscore diff12 SV for state variable at the end. The first case is if there's a difference. The second case is if there's no difference. And then the conditional expression is right here. Basically, if the reservoir 1 storage is greater than reservoir 2 storage, or the opposite, reservoir 1 storage is less than reservoir 2 storage. There were operators of and, or, and not, but there's also a logical operator in Russell Plus, which is not equals, but I don't think it's allowed in the condition expressions. But you're welcome to test that out if you want. Just wasn't working for me. Finally, the actual value of this store diff12 SV variable is assigned the absolute value of the difference between the storage in reservoirs 1 and reservoirs 2. Okay, also I do have a -1 assigned, which means I'm actually looking back one time step. I wasn't able to actually evaluate it at the current time step, and I think that's just because WRIMS hasn't performed the calculation yet. All right, the other case right here uses a condition and then always. Always is probably what you want to use for the condition of your last case. Regardless of how many cases you have, you want to have some sort of catch-all situation like if else, if else, if else. Else would sort of be like your always, your catch-all, just to ensure that your state variable has a value assigned to it. All right, down below here, I've actually added a decision variable with almost the same name, and I set them equal to each other here just so it would write to the decision variable.dss file, and I can take a look at that data. It's not necessary to write it to the DSS file. It could be used internally in the code, and that's what we're going to be doing a little bit later in the lesson is referencing this state variable right here. All right, so let's go ahead and run it and then see what we get for this storage difference 1, 2 variable, which should show up as kind storage and units in basically the same units as the storage in our reservoir. So I'm going to save this file, go over to Eclipse, and then right click, run as, and then run. Okay, that ran. I'm going to open up DSS View. We should see a new variable pop into place here when I go View, Refresh Catalog. Okay, here it is, storage difference. Let's take a look at the plot. Okay, that's interesting. Let's actually compare this with the actual volumes of water in both Reservoir 1 and Reservoir 2. Okay, here's the plot. Here is Reservoir 1 is in red, and then Reservoir 2 storage is in yellow, and then the difference, the absolute value of the difference is stored right here in green. All right, we can also use conditionals for goal statements, which are constraints. Back to the reference manual and on our way to page 18. Okay, here we are. Conditional goal statement. The constraint can be specified based on a condition. It gives us the general format right here. Goal, and then the name of the goal, open bracket, left-hand side, and then you want to indent, then the case, open bracket, then the condition, then the right-hand side, and then whether or not it's a constraint or a penalty. And then like the question mark symbol right here, I believe is a regular expression notation, meaning 0 or 1. And I would also implore you to use this exact format where you go goal first, then left-hand side, then case, then condition, then right-hand side. I was messing around with putting both left-hand side and right-hand side up here, or both left-hand side and right-hand side down beneath the condition. Neither were working for me, but when I used this exact format, it was working for me. So anyway, if something's not working and your actual format isn't exactly like this, then try to format it to something like this. Down below here, we have an example. Now, these examples like to use the month instead of February. Now we're checking if the month is April. So go ahead and use some of these examples too if mine aren't good enough. But let's go ahead and do this. We're going to add a constraint to our WRIMS application. I'm going to go to the constraints file here. We already have a bunch of constraints. This is the constraint I want to modify. Currently, what it's doing is it's saying what it says, encourage reservoir volumes to remain equal. So both reservoirs are both equal in their storage. And what I'm doing here on lines 18 and 19 is assigning a penalty in the event that there is a deviation between the storage of water in Reservoir 1 and Reservoir 2. But what I'm going to do is just delete that and then paste in some similar looking code that also takes advantage of our state variable right here, which is what we just defined. So let me go from the top here. Again, we're encouraging both of the reservoirs to remain equal. The goal is going to be called res1, res2 equal. Goal is a constraint. Here I'm defining the left-hand side, and then we have a case ASDF. Okay, I renamed the cases to diff 400 plus, diff 0 plus, and diff 0. So sorry about that, but those are the names now. And what they refer to is this first case is if the storage difference between the two reservoirs exceeds 400,000 acre feet, then this is the right-hand side, and then these are the penalties. I've just increased the penalties to be 0.8 instead of what it was, 0.2. This is the original case down here at the bottom. And then secondly, there is a difference in the reservoir storage, but it's less than 400. In that case, we're going to have a penalty of 0.6. Some of these penalties you just kind of have to play with. And then the last case is the default where we have condition always, and I'm just going to default to the original 0.2 penalty. Yeah, the way these conditional statements works is they'll work from top to bottom, and then once one of these conditions evaluates to true, then the code inside is evaluated, and then all of the subsequent cases are ignored. So if all of the cases are untrue, then that's why this condition always is kind of the default case that should catch all of the extra runs that don't satisfy any of the previous conditions. Okay, so let's go ahead and save that and then run the model one more time and run. Okay, let's check out our results. So right here in DSS view, refresh catalog. Okay, I'm going to open up the same pass as before, reservoir 1, reservoir 2, and the storage difference. Here it is. Okay, so in red we have reservoir 1, and then that's the storage. In yellow is reservoir 2, that's the storage. And then in green, this is the difference. There's much less difference than we saw previously because we've increased the penalty if there is a difference. And we did that using the variable which we calculated or defined that state variable using a conditional state variable, and later used that variable and its value in a condition to modify the penalty associated with any deviation between the storage in the two reservoirs.